Now, let's go to the next step, which is exploring data set or EDA step. Data exploration is a crucial first step before we do anything with the data, because we got to first understand the data, what kind of data that we have, in order to really plan out what we want to do with the data, like, for example, cleaning and pre-processing. The goal of the initial data exploration is to understand the structure, quality, and characteristic of the data set, enabling us to make informed decision about handling missing values, outliers, and inconsistencies. This process ensures that the cleaning efforts are targeted and efficient, prevent unnecessary modification that might distort the data set. Effective data exploration leads to a better pre-processing and ultimately improving model performance and insights into data analysis. And I have listed some of the common methods to explore the data. Again, just to let everyone know that these are not the only ways you can explore the data, but one of the common methods that I use and most analysts use in order to explore the data in Python. First, I already went over this, but we can use .head to take a quick look at the data and this function shows first X rows of the data set. You can specify a number in the function if you want to see any other number of rows other than 5. The next, there's a df.describe. So .describe function shows a numerical statistics of the data set. I'll be showing you how it's used really soon, but basically it shows all the core statistics of the data set, but it only shows that statistics for numerical columns like float and integers. Next, there's .info function. .info is a built-in Pandas function similar to describe and head, and it shows what kind of data type each columns are in the data frame, and it also shows how many non-null values there are. And we can also use data visualization tools like basically plot out the histogram and box plots or any other plots to really understand, hey, how our data is distributed, or if there's any like weird values within our data, etc. It is like easy and quick and easy process to take a really high overview of your data, and it would also give you like a preparation for the real or final output visualizations. So it is nice to do in the beginning to see what kind of visualizations the data will output. And lastly, you can use .value counts by specifying a specific column name here. This function basically shows a histogram or value counts within each column. I think it will make more sense when I actually show you here. So let's put these into an action. So let's see. Let's first look at the employee survey data, DFE. DFE, and then we already used head, so I'll skip that. And I'll go into describe. As I said, describe shows a numerical value, a numerical column is only. Right now, it's only showing employee ID. And let's see what kind of statistics it's showing. It's showing the count. It shows how many non-null values there are in the data set or in the specific column. And it shows mean, standard deviation, min and max value, and different percentile values. It's very useful to have a quick look at the distribution of the values within the column. This is something that is interesting because when we run the DFE or DFE head, you can do either. You can see that there are 4 different columns, and it looks like 3 of the columns that is not showing on the describe function are numerical. So let's see what's going on here. So let's take a closer look at the data frame using an info function. Once I run the info function, it's going to show 4 different columns, basically all the columns within the data frame, and it will show all the non-null values. So there are 410 non-null values. So all the columns have the same number of null, which most likely means we don't have null values inside this data frame. However, this is very interesting how the data type is showing the first column is an integer. That's why it showed up in the describe function, but the rest are an object. Object basically means it's a string. It is not a numerical value. So the computer or Jupyter Notebook or the Pandas doesn't really recognize this column as a numerical value, but it recognizes as object type. So later we need to remember this, and we need to make sure we convert these columns into a numerical value so that we can take statistics, or we can basically run analysis and on this data set. Let's take a look at DFM data set, and let's go to describe. So when we run describe function with the manager survey data, you can see that all the columns are showing, which means all the columns are numerical values. You can see that the job involvement, which shows a score of employee, ranges from 1 to 4, same as a performance rating. There's nothing much to note there other than that. We're going to be looking more closely later on when we do the analytics. So let's now go into DF general, or let's just confirm if they're actually numerical values. And you can see all three columns are integer data type. And similar to DFE, the employee survey data, there's 4,410 values, which most likely indicates there are 4,410 employees in this company. DF general, let's do a describe. Let's run it. So this data set has a lot of numerical columns. First, let's look into the age. This is interesting. The mean age of this company is 4,000 years old, which doesn't make sense at all. And you can quickly see that this is most likely due to the fact that there are people who's written as having an age of 9,999, which is probably erroneous data, some sort of system error, data entry issue. It's showing 9999, which is clearly not reasonable and faulty data. Therefore, we should remember to do something about this data points. And we're going to be learning how to deal with this kind of erroneous data later on. And I'll quickly skim through and see if there's any weird or something that has comes to my eyes, anything weird showing. But yeah, I don't see anything weird just pop up in my eyes. Maybe we'll catch something else later. So this is basically some of the tools that we can do, we can use to do a quick EDA, basically exploration of the data. So we first discovered these three ways of dealing with the data analytics. Now let's go into visualization and value counts. Before we go into visualization, let's talk about the value counts. So how you use value count. Let's go back to the manager survey data. So let's say that we are curious on how many employees received for performance rating of 1. If we're curious about that, we can simply use the value counts function. First, we need to specify a specific column that we are interested in. So we are interested in performance rating, and we just type in dot value counts, which will output basically the value count distribution of how many of each value is within the column. So for example, majority of the employees have performance rating of 4. However, there are some employees with 3 and 2, and small proportion of our employees have performance rating of 1. So this means this is like a and this is a very useful tool when you're quickly taking a look into a data set. Visualization we can do to understand the data. So right now the goal is not to create the best plot possible, but just to use a plot or visualization tools to understand the data. So let's see, let's choose one of the columns. So um, let's take a look into the age column within the DF general data set. So again, well, we have these two different libraries that we can use to plot. Let's first use this matplotlib.pyplot to plot out the histogram. Since we have imported this library using an alias or using the name PLT, we can simply use plt.hist. Basically, it stands for histogram, and assign input the data that we are interested in converting into histogram. So let's do a df general and age. So now when I run this, it's going to show a histogram of df age within the df general dataset. Unfortunately, this histogram is not showing much other than that there are a large proportion of the data which is showing 9999 as an age. So we know that we need to deal with its data. Let's take a look at other column. So we're looking into distance from home. Basically, it tells you how far the user lives or employee lives away from the company. Um, and you can see the majority of the employee lives with very close to the company. I'm assuming this is in kilometers. It could be in miles. I have to take a look into the data context. But regardless, majority of the employees live close to the company, and um, and the distribution drops from there. So it's a heavily skewed to the right data set. And we always like to use plt.show at the end of the core end of the code, because that basically cleans up any other unnecessary output. And the plot might show, for example, like if I run it without the plt.show, if I comment it out to make it inactive, if I run this, and you can see there's like a lot of unnecessary output that is showing. So if I just want to see the plot, then I just run plt show, which will only show the plot, and then I can use other functions like plt title, which basically assigns a title to the plot that you're plotting and give a name. So I want to name this plot a distribution of distance from home, and I'm going to assume this is for kilometers. So if I run that, now it has a title that we have assigned to the plot. So this is a very useful tool and process. There are other functions that we're going to be going over to make this plot more legible and more understandable. But we're going to be stopping here for now, because our goal is not to, again, not to create the best plot ever, but to really understand the data. So let's try to use a for loop to basically create a histogram of all the numerical value columns inside of the DF general data set, because that would help us, because we don't want to go individually copy and paste the column name and create the data set individually, create the plot individually. We want to make automated process so that we don't have to do it over and over. So I'm gonna be controlling Z to get back the comment that I used. So Here, I'm going to be using a for loop to um, basically loop through some of the core or some of the numerical columns that I'm interested in. I'm going to be calling the list of column names called numerical column names. And then I'm going to create a list, and I'm going to copy and paste some of the columns that I am interested in. So the first column will be age, and then I'm going to be plotting out distance from home. Then I want to plot out, let's choose something else. Let's see, years at company. And lastly, last years since last promotion. So I have basically pulled the list of column names into a list and assigned it to the column name variable. And I can run the for loop on this list. Basically, I'm running a for loop on this list, and each time each column name will be named call. And then I can use a PLT histogram, PLT hist, to plot out those columns. So instead of manually specifying the column name here, I'm going to be automatically doing that using a call, COL. And I'm going to be naming the title, basically titling it, using the column name again. Let's see what happens if I run this. Nice. So as we wanted, now it's plotting 4 different histogram plots, which we specified up here. It gives a individually different title, which corresponds with the column name and the distribution. This is a very useful tool. And just quickly looking at the distribution, nothing seems weird or off except for the age. So we know that we need to deal with the age. So that's how you do a quick visualization to explore the data quickly. And again, we're going to be going into more details about the data visualization later in this lecture. Now let's move on and learn about how to clean the data.